Bueno, buenas tardes. Mi nombre es...
Good afternoon. My name is Gonzalo Galotti. I work at the GenAccess development team and the web team. Also, on my spare time, I'm the developer of the application called Fútbol Uruguay for soccer, which has been developed by GenAccess for mobile devices, which is meant for following the Uruguayan soccer. This presentation will be about scalability and performance, which are two subjects that I have always found very interesting. Just to give you an idea of this, I want to show you this video.
Bueno, espero que no...
Well, I hope there is no British in the room. So I'm very happy because my application has a large number of users, like 80 or 90,000 users, but I've just sent a notification to my 60, 70,000 users. So I was so happy, but I didn't stop to think what would happen if all of those users decide to open the application at the same time. These soccer applications have a very special use pattern because sometimes there's a huge number of them trying to log on at the same time. Probably my server will be prepared for that. They will be receiving errors. Maybe my server will be sort of saturated, and some of the users might not be happy about that. So how can we be prepared for this? Well, one thing is to change the server to buy another one, a bigger one. Even though this would seem to be a solution, what would happen if tomorrow I double or treble the number of users? So this solution will no longer be applicable, so this is not a good one. Another is to add a load balancer to put more servers and to do this on a more distributed way. I think this is better. This is a sort of a definition of scaling an application, which means which is about the capacity of a system which on a certain demand can adapt correctly. And this technique of adding more servers is called to scale horizontally. So this would seem to be the solution that we need to apply to our applications, because it also ensures other features such as availability. It makes you more, gives you more fault tolerance, because if there's one server that fails, others will be able to work, and the application becomes more predictable, but not so fast. By scaling, you also need to take into account a series of architecture-based decisions and not just scaling. Some of those decisions are these ones. In order to improve the performance of your application, you need to understand about caching. It needs to be scalable. In terms of storage, you need to understand how your applications can work in a scalable environment when they're distributed. There's also database replication, load balancing. You need to know how to use the web session. And finally, something that's so trendy now in mobile applications is how to scale push notifications. The good news is that there are major players that have invested a lot of money on the cloud. For example, Windows Azure, IBM, Amazon, SAP, Rackspace, Montevideo.com. And they have all developed interesting services so that we can scale our applications within this infrastructure. Something you need to bear in mind is even if I have applications being hosted in Amazon or IBM, it does not mean that my application is scalable. For it to be scalable, you need to bear in mind some considerations. So, to have an architecture that encompasses all of this is somewhat complicated. So this is where we want GeneXus to come into play so that all these ingredients can be united with all these players in order to create a truly scalable architecture. So here on this presentation, we're going to focus on 3 pillars: storage, caching, and push notifications. First of all, let's understand why we need to scale storage. Just a couple of examples here. And these examples are real-life examples from the soccer application. When a user wants to log on to the application to see the pictures from a match, this happens. A GET request is triggered to the web server, then it realizes that there are images, it goes to the database, then everything is zapped on the hard drive of the web server, and then it gives back a response. Then the client needs to request the images to the web server, binaries are obtained, and they're deployed. This is a typical scenario of a web application. But what are the problems here? If tomorrow I need my users to be able to upload videos from matches, images from the goals that were scored, all those binaries will be stored in databases. So my database might grow without control because everything is stored there. The web servers also serving dynamic content, so they're competing for bandwidth. And finally, something that's not good in terms of scaling is to use the existing web server. So if we have here, instead of obtaining a binary, we obtain an image reference, and the client goes directly to a storage provider that is outside the web server. So the idea behind this storage scaling is to take resources from the web server and from the file system so that they are in a centralized way. This makes the application quicker and it favors scalability. What are these blue baskets that you have there? These are storage providers. Basically, what storage providers do, they're a place for storing files. Most cloud providers have one. Here I'm showing Amazon S3, which is a place for cloud storage. This gives interesting features such as high availability, caching, performance. It's really affordable, so cost does not seem an excuse for not using it. So how do we want to have all these storage providers getting into GeneXus? The idea is that anyone can configure what storage provider to use. Here we'll have 3 flavors. I'm not so much interested in terms of scalability, so maybe I will say let's have one server for that. But for those of you who are interested in running your application in a distributed way or who are on the cloud already, you will have a flavor for that. You will have implementations for Windows Azure storage or Montevideo.com, whatever is relevant for that time. And finally, for those of you who are deploying applications in a private network, in a private cloud, if you want these applications to be executed in a distributed way, you will be able to do it with your own provider. So this is where extensibility comes into play. The final idea of this is that no matter whether I'm working on a transaction, a procedure, or in SD applications, when I want to update a blog, an image, a file, audio, or video, GeneXus automatically synchronizes changes automatically according to the provider that was chosen. Also, from a security point of view, we will introduce a new concept, which is that we will be able to tell one resource whether access is private, and when it is private, the only way of accessing it will be through a signed URL with a time of expiry. In this way, we are protecting files that are private. This, which we've just seen, and this is what we're actually developing for the next GeneXus version, this will allow us to foster scalability and the performance of our applications. In terms of caching, web applications usually have a read-write ratio of around 80-20 and 90-10. So from here we can deduct that if we can scale these read-write operations, we will be able to improve our apps. To improve this, one tactic is to use caching techniques precisely. But what is caching? Caching is one technique that basically aims at reducing access to resources that are very costly in terms of time and processing, for example, databases, file system, or other services. That's what they aim at solving. They give a series of interesting features in our applications, but what is GeneXus offering today in Evolution 2 or 3 in terms of this? GeneXus already has 2 levels for caching. One level for smart devices, which avoids pages from being refreshed if some data didn't change on the server. That's activated by default. And on the other hand, we have a caching level at a database level. To understand this, this is not so widely used, maybe because people don't know about the existence of this tool. To show you a case, this is a real-life example of the application. In several parts, we have seen a parameter table, and we are calling this permanently. And we said, why instead of accessing our database every time, why don't we cache this table? And then we can access it directly without going through the database. From GeneXus, it's very easy to do this. We do this in 2 steps: table properties, and then we select change frequency, and cache is activated just by doing that. So we said, let's test this. So we installed in the Montevideo.com servers, we installed the soccer application in .NET language. We ran a stress test on one resource. It is a quite complex thing over a series of tables. And we obtained a result of 500 dB per second. Then the server was sort of saturated. We chose 4 strategic tables in the application. We did the test again, and then we were able to increase the server by 4 times, increase the performance by 4 times in the server. This has given tremendously good results. So I encourage you to take a look at this because it's a good tool to improve the performance of our applications. So we saw 2 levels that we already have, but what do we want to incorporate now? This is what we call service level cache. And the idea behind this is the following. When I open my application, in the match screen, we see comparative information between 2 teams. What this does from a programming point of view, we call a series of procedures, and one of them calls an external web service, which is a data provider, and this data provider sometimes takes 1 or 2 seconds. It's a call stop to another server that is the one that has information. But what happened here is that when the number of users started increasing, this became more complex. It started to take longer. And sometimes the external web server was crashing, so we had to change our method. And instead of doing this, we said, why don't we find it in the cache directly without having to go to the external web server? So this is more or less the same at a service-based level through business components. So this is the idea behind this. It's a concept that could be very interesting and important to improve the performance of our applications. I also want to tell you about another flavor that we have in this service level cache, which is HTTP acceleration. We want our applications to be compatible with this. An HTTP accelerator is a software or hardware piece that is in front of the web server. It acts like a proxy. Actually, 90% of Java applications are running behind a proxy. What is this accelerator good for? Let's assume this scenario. I have an application in the US, I have a client in Japan, and my accelerator is in Japan as well. When the client opens the application, a request is triggered to the accelerator in Japan. Since it is a proxy, it goes to the web server, then the web server responds. Since GeneXus said this reply could be cached, so what it does is to save the information in the accelerator in Japan, and then it responds. Then another client opens the application, but now the accelerator, instead of going to the web server, it obtains information from the cache, because GeneXus had said that this response could be cached. So it returns that response without having to go to the web server. So there's a less consumption of bandwidth, processing, database, etc. In other words, I'm improving the response time of our application and the user experience. So this is more or less a tactic that we would like to include. And this is the tactic that FIFA used in the application of Brazil 2014 that allowed it to serve 30 million users in its Android and iOS applications. So we want our applications to be able to benefit from this too. Finally, we have seen these three cache levels, but this is good for not going to the database, to the hard drive. But where will this information be stored? For this, in GeneXus, we are incorporating storage systems that are specially optimized for caching. Two examples that we are adding. I think this is already implemented. In Claudio's case, we are working with Redis, Memcached, which are two storage systems. Actually, they're used in Twitter, Facebook, and YouTube, and they specifically serve for storing information of fast access. For those of you who are in the cloud, we will have integration with Amazon Elastic Cache, which works on the cloud, and it is managed by Amazon. I think this is what I wanted to tell you about caching. It's a very important tool. These technologies are incorporated in this version in order to improve the performance of our applications. And the last thing I would like to mention, I'm going to be very brief. I'm going to talk about push notifications, which are essential in terms of soccer applications because they tell you when the match begins, when a goal is scored, etc. So far, we have sent 2 million push notifications. We have sent 150,000 push per month. And we've even sent 50,000 per second in the most widely seen soccer matches. How did we do this? Through a platform that's specially optimized for sending notifications, and we would like to have in our next version to be able to use this provider in order to scale in an endless way our notifications and applications. What I would like to comment in this presentation is that the applications that we're building are more and more complex, and they need to have more elements. And GeneXus needs to be ready to build any type of application, whether large or small. So we are introducing new systems for storing data, new systems for caching, systems like Reading and Memcache, and the push notifications mechanism that I mentioned. Even though in this presentation we went into detail into 3 pillars, in GeneXus we're trying to focus on the whole architecture so that all of these ingredients can jumpstart our architecture, and always having in mind that it's important to integrate the services that are offered in the cloud. So this is what we're doing now, and we will continue to work on this in the next version. Thank you very much.